Hello, welcome to my channel. My name is Mark Harris. Today I'll be talking about diagram 3 and explaining how it works. First I want to explain that there are two series connections in this diagram. B and C are connected in series, and R1 and R2 are connected in series. Now A and B, that is a parallel branch, and C and D is a parallel branch which is connected electromagnetically to E and F. So to begin with, here we have a AC source, 120 volts, and or it can be a wall receptacle, duplex receptacle outlet. So first we connect, we make two parallel branches, A and B and E and F, which is electromagnetically connected to C and D. And this is a one-to-one ratio no-step isolation transformer. And what it does is isolates E and F from C and D because they're not electrically connected. They're electromagnetically connected. And they should be, this transformer should be a 240 to 240 volt transformer, not a 120 to 120 volt transformer. But we're passing 120 volts through the 240 volt transformer and getting 120 volts coming out. But because we're going to add these two parallel branches in series here with B and C connected, you're going to have 240 volts present at secondary coils of this transformer. And you have to do this because you're going to have twice as much electrons bouncing around, and it'll warm the coils up faster, depending on how large a device you have for the load. So now over here, there's two devices, R1 and R2. I have the example here of 200 watt light bulbs, 144 ohms each, requiring 833 milliamps. So what happens here is you got 240 volts present between G and J. And first, if the current comes this way through R1, it goes through R1 first and drops 120 volts over that. And then it drops another 120 volts over R2. But what happens is it passes 833 milliamps through R1. And because there's still 120 volts left over, it passes the same current that was used for that light bulb to go through the second light bulb. And then when the direction changes, alternating current, it goes through R2 first and then through R1. Now, I think that's all I had to say about this, to explain it all. But this is this series connection here is what is the secret here. Oh, I want to note, if you wire up the secondary coils wrong with point B, you're going to get 0 volts. And if you do it right, you're going to get 240 volts between A and D. So you don't have to worry about wiring it up wrong, because it's either constructive interference or destructive interference. So there's no harm in, there's no worry that you're going to short something out. And if this was electrically connected here, if E and C were joined like a wire, then this would short out through here. So that's why you have to isolate this circuit through this with this isolation transformer. Okay, I think that's all I had to say about this circuit. But I'm going to be sharing diagram 9, which is something very exciting what this can be used for. And first I'll do diagram 8 and explain that first, and then I'll do diagram 9 And then later diagram 11, which is something that a circuit that where it's all kept at 120 volts. You don't have to worry about 240 volts, because I drop it down to 60 volts first, and then I make 120 volts out of it. Okay, I guess that's all I need to say. So thanks a lot for watching. See you later. Bye.